Hello everybody, it's another maths lesson, and today we're going to be looking at what the words factor and product mean in maths, and we're going to look at a puzzle that involves factors and products and that needs some systematic thinking. So let's have a look at this. The words factor and product are words that are in maths to do with multiplication. So let's have a look at them here. Let's have a look at this example. We've got 6 times 2 equals 12. Well, actually here, the product is 12. The factors are 6 and 2. In this number sentence, 6 and 2 are the factors and 12 is the product. The way we think about it is that a factor here times a factor makes a product. So 6 times 2, 6 and 2 are the factors, and multiply them together, they give us the product 12. And normally in maths say that factors are whole numbers, so 1, 2, 3, not 1.5, but could be. Factors are whole numbers which we can multiply together to get another number. And the product is what you get when you multiply two numbers together. So let's have a look at this multiplication. It says 3 times 5 is 15. Remember, factor times a factor makes the product. So, shall we fill in the gaps? You pause the video and have a go. Did you pause the video? I hope so. In this number sentence, well, the factors, the something and something are the factors. 3 and 5 are the factors. And 15 is the product of 3 and 5. So, let's have a look at this one. It says this one is the other way around. Can you see? It's the same kind of multiplication, but written in a different order. So 12 is the same as 4 times 3. Pause the video. Can you fill in the gaps? Hope so. In this number sentence, well, the factors, remember, it's the factor times the factor makes the product. So, in this number sentence, 4 and 3 are the factors, and 12 is the product. Okay. And one of the things that it's useful to be able to do in maths is to find all the factor pairs that make a product. Factors, we're going to normally find them in pairs, aren't we? Because it's something times something, so two things. Some numbers are the product of only one pair of factors. For example, when we want to make 17, 1 times 17 equals 17, we can change the order and do 17 times 1. It is the same factor pair, just the order that is different. You can't find two different factors that make 17. 17 is what we call a prime number. A prime number. And you learn much more about that in year 5 and year 6. And prime numbers are actually very important. They get used in a lot of internet security and code cracking online. And in computer games as well. Computer games use prime numbers a lot. So prime number only has one pair of factors. So 1 and itself. But most numbers are not prime numbers. And in fact, some numbers have a lot of factor pairs. So here's a question for us to think about. 24 has a lot of factor pairs. Something times something equals 24. So I might ask you, can you find them all? And the question means, what are all the pairs of numbers that multiply together to make 24? So, how can we start thinking about that? I mean, we could just start thinking of times tables which have 24 on. Is that a good way to start? What do you think? Maybe you could try and find all of the factor pairs. Pause the video. I hope you paused the video, because our other learning objective today is to be systematic. Means using a system to find all the factor pairs. Instead of just starting anywhere with any times table, let's start with the 1 times table. Now, every whole number is on the 1 times table. So 1 times 24. That makes 24. We could put 1 and 24. Is 24 on the 2 times table? Yes. All the even numbers are on the 2's. 2 times 12. So 1 and 24 is a factor pair. 2 and 12. Is 24 on the 3's? Yes, it is. 3 times 8. Is it on the 4's? Yes, it is. 4 times 6. Is it on the 5's? No. All the numbers on the 5 times table end in 0 or 5. So 24 is not. I'm going to put a line there saying that's not. Is it on the 6's? Well, yes it is, but we've already done that, haven't we? 4 times 6. So I'm going to put a tick to say, yeah, it is, but we've already done it. Is it on the 7's? Well, 7, 14, 21, 28. No. Is it on the 8's? Yeah, I'll put a cross, that might make more sense. Is it on the 8's? Yes, it is. We've done it already. Is it on the 9's? 9, 18, 27. No. Is it on the 10's? No. All the 10's end in 0 in the 1's, in the units column, the 1's. Is it on the 11's? 11, 22. No. Is it on the 12's? Yes, it is. We've done it already. So I'm going to tick it. So, what factors did we find? Well, the factor pairs 1 and 24. Whoops. 2 and 12. 3 and 8. Oh dear, I've run out of space. 4 and 6. And we were working systematically. Why? Because we started with the 1 times table, then we tried the 2's, then we tried the 3's. So of course, that way we won't miss anything. And you can use the times table sheet for this. Okay, now here's a puzzle. It says that the number in each rectangle, so let's, for example, look at this rectangle here. Can you see it? 15. The number in each rectangle is the product of the numbers in the circles on either side, which means this circle times this circle makes 15. So something times something equals 15. Okay, well, it could be 1, I'm going to think systematically, 1 and 15. 15's not on the 2, so not 2. It could be 3 and 5. Well, it's not on the 4's, it is on the 5's, but we've said that already, 3 and 5. Okay, so now I've got to think. I've got 3 and 5 to put in these, or 1 and 15. Well, I'm going to look at the other numbers now for a clue. Well, 20 is definitely on the 5's. So I'm going to try putting the 5 there and the 3 there. I can always rub it out if it's wrong. Let's see, is it going to work? Now, If it's 5, how many 5s make 20? 5 times something equals 20. Well, let's see. If it's 4 here, and then it works this way as well, 4 times 3 is 12. Oof! We got it! We got it. Do you see how I worked it out? I took one of the factors, one of the products, worked out what its factors could be, and then I looked around for clues. Shall we try another one? Let's try another one. Okay, well, here the numbers in the rectangles are 24, 18 and 12. I'm going to start with the smallest one because the chances are it won't have so many factors. So it could be factors of 12. Well, 1 and 12. 2 and 6. 3 and 4. Ooh, it's tricky. It's tricky. I wonder, what shall I try? What shall I try? What shall I try? It's not completely obvious because 24 and 18, well, 18 is not on the 12s, 24 is. I wonder, this might be a chance for me to just try it. How about if I put 3 here and 4 here? Well, 3 times 4 is 12. 3 times what makes 24? 8. Oh no, but 4 times 8 is 32. So that shows me, no, I was not right on that one. So this means where I might need to go back and rub it out and have a little go again. So not 3 there and 4 there and 8 there. How about I try it the other way around? How about the other way around? Oops. 4 there and 3 there. 4 times 3 is 12. 4 times what makes 24? 4 times something makes 24. Oh, 4 times 6. 6 times 3 is 18. Phew! Okay, your work today. There are 2 levels of work. You need to find, for the first level, all the factor pairs for these numbers, all the factor pairs for 20. Remember to think systematically, starting with 1 times, then trying 2 times, trying 3 times. And on the other side, a little bit trickier, we've got 4 of these puzzles to have a go at. And you'll need to think about finding all the factors and then trying them, looking at the numbers. Give it a go and enjoy. Looking forward to seeing your work. Bye!